Hi, I'm Matthew Wickham, the Chief Scientist at Posit, and for the purpose of this video, the Chief Maintainer of the Purrr package. So what is the Purrr package? It's kind of hard to describe what Purrr is, to be honest, but to put it into words, I think I've got a pretty good sense of what function feels like a Purrr function to me. But I think the best way to think of it is a toolkit for supporting functional programming. What is functional programming? That's also kind of hard to explain. The chief advantage is it gives you a bunch of tools for operating on vectors or pairs of vectors or triplets or etc. vectors, where you work on each individual element of the vector in isolation. And that allows you to apply a function to do something to each element, knowing that there's no way that the other elements are going to affect the computation at all. So many of the functions of Purrr are alternatives to for loops. For loops are by any means not a bad thing. You should never be embarrassed or ashamed of using a for loop. For loops are great because they're very, very concrete. It's very obvious what you're doing, because you're doing take this element and do this to it, take that element and do that. And you can very easily think about stepping through that vector. So the functions in Purrr, particularly the map functions, are kind of a step up in abstraction. And that step up is, it's a challenge, right? But I think there's some good reasons to do it. And the first one is it makes it easy to avoid, or ensures that you avoid some performance bottlenecks with loops. Now, for loops themselves are not slow, but if in your for loop, it's easy to accidentally repeatedly modify or repeatedly extend a vector, and that can be slow. Although changes in the latest versions of R have made that much less bad than it has been in the past. So performance, a little bit useful. I think one big advantage of switching to Purrr is that you can also switch to, oops, not future, but the Furrr package. So the Furrr package has exactly the same syntax as Purrr, but it spreads the computation across multiple cores. So Purrr, because it guarantees that all of the computations are independent, much easier to share that work across multiple cores. The other thing, particularly in this latest version of Purrr, is that it gives you access to a really powerful and useful tool, and that's progress bars, which I'll talk about a little bit later. But Purrr, definitely kind of an advanced programming tool. You can go a very long way with for loops. But I think if you can master the map functions of Purrr, you can write code that is more succinct, more clear, and more likely to be correct the first time you write it. So today I'm going to talk about Purrr 1.0. And the 1.0 release of any package is pretty special, because this marks the package as at least the initial development is kind of done. This is a package that we are confident about, it's stable, and we expect it to be around for the long term. And for Purrr in particular, this is kind of an opportunity to take a look at it broadly and say which of the functions in this package are really related to the core purpose of functional programming, of working with vectors and functions, and which functions in Purrr are not, and maybe need to be superseded or deprecated. So why don't we start with some of my favorite features of the Purrr 1.0. And I think the most exciting feature, or the coolest feature, is the new progress bar. So let's just make a very silly little example. Let's take a brief look at what life is like without progress bars. So let's just imagine we're going to map over 100 numbers, and in lieu of doing anything useful here, I'm just going to sleep. I'm just going to pause for 10 minutes. So I run this code. I know something's working. I know this is going to take 10 seconds in total, but I'm getting no feedback on what's going on. And for a real life job, you don't know exactly how long it's going to take. And you don't know when something's happening. Should you just take a deep breath? Should you go grab a coffee? Or should you come back tomorrow? So what's great now in the latest version of Purrr is you can say .progress equals true and get a convenient progress bar that tells you both how far through the process you are and an estimated time till completion, assuming that every single iteration takes about the same amount of time. Now that alone I think is pretty great for interactive usage. if you are putting these inside of a function, you can add here, instead of just a true, you can add a string, which will be used as a label for the progress bar, so you know exactly what's going on. Okay, so my next really useful feature, instead of a part of a big push across the tidyverse, is better error messages. So again, I'm just going to make up some dumb kind of sample data I've just taken, the numbers between 1 and 500, and randomly reorganized them. And I'm going to make a little function. And this function is, most of the time, it's just going to double that number. But every now and then, it's going to have an error. Again, I'm just kind of simulating what might happen in your real code. Not particularly useful by itself. But now if I run this code, what's really handy is map is going to tell you exactly where that error occurred. So I can look at the 318th argument, and I know that's 1, 2, 3, which by inspection of this function is pretty easy to determine. But in real life, this is really helpful at like figuring out exactly where that problem occurred. Now, of course, you can still use all of the useful functions in Perl, like safely, and possibly if you expect errors and want to capture them some way. But this new ability to tell you where the error occurred is hopefully something that's helpful and just makes your life a little bit easier every day. We've also generally just like reviewed the error messages elsewhere. Again, as part of this kind of big tidyverse effort to make sure you get better error messages. Maybe I can, is there some way I can show that to you here? So maybe if I try and supply an environment or something weird instead of a function, now we have this pretty standard kind of error framing where we try and tell you like what went wrong. It was an environment. What did we want? A function. And you'll see this more and more as we work on improving error messages across the tidyverse. We also have a new map function called map_vec. So if you're an existing Perl user, you probably know about map LGL that produces a logical vector, map int for integer vectors, map double for double vectors, map for character vectors. You might wonder, like, what about all the other things? Like, is there going to be a map date? Is there going to be like a map factor? Is there going to be some kind of map thing for every single possible type of object in R? This is something we've been struggling with for a while in Perl. We can never quite figure out what to do. But there's now a new function called map_vec that's going to work with any type of vector object. So anything like a factor or a date or a date time is now going to work. So for example, I could map over the numbers 1 to 3 in my function. I'm just going to add those to today's date. That's going to give me another date, and that's going to give me a vector of dates. Or I could take some letters, first 3 letters, L, turn that into a factor, and then when I use map_vec, it's going to give me a factor, just as you expect. So it uses the rules from the vectors package. Vectors is a package that hopefully you as a data scientist don't need to care about, but it's something that we're using more and more in the kind of the depths of the tidyverse to make sure all of the rules that we use are consistent. So you don't have to memorize these rules, but hopefully as you use functions from around the tidyverse, you just naturally over time learn what those rules are. You might not be able to make them explicit, but because everything is consistent and behaves in the same way, you build up this internal knowledge of the theory that underlies these conventions. One thing I should note about map_vec is it's kind of one of its invariants, one of its things that are always true, is that the length of the input is the same as the length of the output. So if you try and create a new vector, maybe I'm going to try and just double every element. That's not going to work. And again, I'm going to get this error message telling me what is supposed to happen. Every element has to be size 1. And in this case, I've got an element of size 2. So what happens if you do want to do something like this? Well, you can do this with map. That's going to give you a list with each of those components. And new in this version of Perl are a set of functions called listc, listRbind, and listcbind, which lets you take the output of functions like this and, for example, combine them all into a vector. Again, this is using vectors under the hood, so this is going to give you exactly the same. It's going to use exactly the same coercion rules that MapVec uses, but in this case, you can use it to produce something where every element is a different length. So, for example, we could take the element and we repeat it a number of times. So we get 1, 1, 2, 2s, and 3, 3s. If we just map that, we can see a list with those elements. And then if we use listc, that's going to concatenate them all into a single vector. So listRbind and listcbind work similarly, except for data frames. These kind of replace, these sort of supersede mapDFC and mapDFR and mapDFC. These functions are super useful, and we know lots of people use them, but they're not really map functions because of this idea of this invariant, that the input should be the same length as the output for a map function. That is pretty important for the meaning of this map. And so we've decided like these functions aren't really that great, so we've superseded them. So if you're not familiar with what that means they are not going away, they're not deprecated, they're not on a path to being removed, but we don't recommend them anymore. So in some sense, these functions are like the safest functions to use because we kind of just put them away and we're never going to touch them. But we just don't recommend using them. So instead, we recommend combining a map with one of these list concatenation functions, whether it's listcbind, listRbind, or listc. So another area of Perl that's got quite a lot of love in this race is this sort of general idea of like flattening and simplification. So this is about like what happens if you've got like some complicated nested list and you want to simplify things. And things have changed like since we wrote this stuff in Perl, like quite a lot of things have changed. In particular, for example, like tidyr now has some really nice tools like unnest longer and unnest wider. So that if you are working with a very hierarchical data set, like you've got something from a JSON API and you want to turn it into a data frame, these tidyr functions are really the place to start now. Previously, you had to use these quite low-level Perl functions. You can still keep using those, but generally unnest longer and unnest wider are going to allow you to express what you want a little bit more simply and a little more clearly. But that means that this gave us an opportunity to look at these functions in Perl and think now, like you're not being forced to use them for these data science operations, data analysis operations. Now we can kind of think about like what are the right primitives here. These are things you're probably not going to use as much day to day. They're more useful when you're programming. There might be tools that we're going to use elsewhere in the tidyverse for solving problems. But we wanted to kind of take a look holistically and think like what's going on. And certainly we caused a lot of confusion in our team. Like we couldn't remember like what does flatten do, what does simplify do. We've had some internal functions and other packages which do other things, and just ended up causing a lot of confusion. Like we didn't have a shared language that we could use when talking to one another. So we tried to like unify things, simplify things in this version. And just to give you like one example, let's talk about the flatten function. So here I have a list. The first element of the list is just a number. The second element of a list is itself another list. And the second element of that list is another list. So we have this kind of complicated like tree-like structure. Now what we can do is use list flatten to remove one layer of that hierarchy. So let's just call it, I'm going to use str again just to illustrate the structure a little bit more easily, and then see what happens. So just give a little bit more room in the console so we can kind of compare them. So previously we had a list of 2 things, now we've got a list of 4 things. You can kind of see what's happened, right? This list, this sublist, of 3 items, it's going to be like pulled up to the top level. So that list itself had another list in it. So we could call a list flatten again to flatten that. And now we have like what we'd call like a perfectly flat list, a list that doesn't contain any other lists. And if we call list flatten on that again, nothing's going to happen. We're still going to need a list. So list flatten is always going to return a list. You don't know how long that list is going to be. It's going to be kind of the sum. It's normally going to increase in size because you're going to have sublists with varying number of children. And they're going to get kind of hoisted up into the parent. But you've made this list as flat as possible. Now, if you want to make this simpler, you can't make this list any flatter, but we could use like a simpler data structure, right? For example, so we could, if we call it list simplify now, we're going to go to a simpler data structure, which in this case is a numeric vector. So let's just illustrate the difference between flattening and simplification with a list that has like a variety of types in it. So the same structure as before, but now we've got a logical in there and a character vector. Let's flatten it. Look at the results. So we've still got a list. We'll flatten it again. Still have a list. Now, can we make this any simpler? Well, what happens if we call this simplify? Well, no, we can't make this any simpler because we're trying to combine a double and a character, a number, and a string together, and there's nothing simpler than a list that will allow you to have both of these in a single data structure. So this is as simple as we get. And this kind of idea, like now we've got this clear distinction between flattening, which is decreasing. You always, when you flatten a list, you still get a list, but the number of items might have changed. And simplification, where you're going to always get something that's atomic vector or a factor or a date, but you're always going to have the same number of items in it. I think has this nice kind of symmetry. Either you're changing the size but keeping the type the same, or you're changing the type and keeping the size the same. And that is a nice kind of split that hopefully allows you to solve problems without getting confused between what different function you should use. So to finish up, I wanted to cover what's possibly like the biggest set of changes to Purrr in this release, which is basically saying these are all the things that Purrr no longer does, that we don't believe that these are actually related to the core purpose of Purrr. And I think this is a really important part of the life cycle of packages, that as we understand what the core purpose of the package is better, we can remove things. And that comes at a cost. If you're an existing user, you might love some of these functions. That refinement hurts existing users, but we do it for the future users, because when people in the future come to Purrr, they're going to see a more tighter, more cohesive set of functions that are easier to understand. So most of these we have like superseded. There are some things that we've deprecated because we think they're really they're pretty uncommon to use them, or there's some major problems with them. So again, most of these will continue to work. Superseded functions will stay around for a long time. Deprecated functions are definitely on the path out, but we're trying to do that as gradually as possible. So if you use a deprecated function in the kind of first release it's deprecated, it'll warn you like every 8 hours that function's going away. We're trying to walk this line between like being annoying enough that you eventually get rid of the deprecated function in favor of the new solution, but not so annoying that it's as bad as just taking the function away. So deprecated functions in this release, they will warn every 8 hours. In the next bigger release, which will be in 1 or 2 years, they'll warn every single time you use them. And then some release after that, probably 2 or 3 years after that, they will error when you use them. So deprecated function, you've still got like a couple of years to fix it, but you really do need to work on that at some point because those functions are on the way out. So let's do a quick overview though of those functions. I'm just looking at the news file, which tracks every single change you've made to the package. if you're like a really big user of a package, I think it's a really good idea to familiarize yourself with these files, because in the blog post, we try and just hit the biggest point, the things that we think are most important, but useful for you to scan the news functions, because things that might be important for you might not be important for lots of other people, or we might just be wrong. Also great, like if you've got, if you've got your own blog and want to find something to write about, like read through the news of packages and look at stuff that we haven't advertised, because I can guarantee you there are useful blog posts to be written about things that we've changed that we're not gonna be writing about. And that's a great way to kind of dig into the development of a package and help educate others as well. So kind of quick summary, cross, I think was a pretty old function. I don't think many people are using it, but it's you're much better off using tidyR's expand grid function. We had a bunch of functions that kind of used non-standard evaluation in some way. There was these just 3 functions in Perl that used non-standard evaluation or tidy evaluation in some way, which just felt like not good fit. So we've got rid of those. So no function in Perl uses, well, no non-deprecated function in Perl uses tidy select anymore. We had the lift family of functions, which I think are kind of a really cool idea. They sort of a little bit mind-blowing about what you can do with functions and functional programming, but it's just an unusual style of programming, and we think that most people are better off not knowing about it. Then we have a bunch of functions that I'm like, I have no idea why we ever included these in Perl, especially these like random number generators ones. I'm not sure why they ever ended up in Perl, but they're now on the way out. And Splice, which is a much older tool that allows you to kind of cram together like lists of lists. We used to use it as kind of an alternative for some of the stuff that we've replaced with dynamic dots or tidy select. Just doesn't make any sense. Other stuff in maps, or things you could do with map functions, that again, I don't know why we ever implemented these, because they're not really vectors, so they don't work anymore. We got rid of the raw variants. Don't think anyone ever actually used them. We've made some changes to how things like map character works. Previously, you could just do something like this, and that would give you a character vector. Now it's going to warn, and the reason we warn is because the way it does the coercion is like pretty weird, and I think there's I don't know if I can. It's pretty weird, and if you're creating like really small numbers, it just like silently truncates them, which is clearly pretty bad. So we got rid of that. Whatever. There are a bunch of other deprecated functions. The previous releases are kind of like marching along the process to going away altogether. So a couple of functions. So here's 2 functions that have gone away now that we deprecated 5 years ago. Now we can finally get rid of them. Yeah, I think those are the main ones. So it's really like, I think part of the really important part of the process of package lifecycle and package development is not just adding new functions, but it is equally important to remove those functions. And we know that removing functions that used to work is frustrating. And so we have developed this process, this lifecycle process of deprecation, where it starts with pretty mild warnings and kind of gets progressively aggressive, more and more aggressive over time. We hope this is useful. We hope that this kind of gradually pushes you towards the golden path without like forcing you rudely when you're working on something else to urgently switch something. But at the same time, we believe that we want these functions to be better. We want these things to have a more consistent, cohesive syntax, because that makes it easier for future users. And I think we're doing pretty well. We've certainly got a lot better, I think, at handling deprecations and breakages, but we're certainly, still trying, still learning. And if you have any feedback, please let us know. But if you're interested in learning more about functional programming in general, I think a really good place to start is Advanced R, which has 3 chapters on functional programming: functionals, function factories, and function operators. And there's a lot of text here, but you don't have to necessarily read the text because I think it's got some really good pictures as well. And this is kind of the basic idea of a map function. You take a map, the first argument is a vector, and you've got a function, and what that gives you as a vector in the result, where you've called f on each element of the vector in turn. And once you've kind of got that idea, then we can kind of scroll down and what happens if you have like a list of elements? Or go down a little bit further, what happens if you supply additional arguments? Or what happens, go quite a few, what happens if you have multiple vectors that you want to kind of iterate through, iterate in parallel? Like, so this, once you, I think these pictures give you a really quick overview of like, what does map2 do? Well, map2 has 2 vectors, and it calls f on the first element of the first one, and the first element of the second one, then the second element of the first one, and so on. And then once you've kind of internalized what map2 does, you might wonder, well, what happens if I've got 3 vectors? Or I don't care about the output. And I think just kind of, if you just skim through these pictures, when we can get into the reduced family and other more complicated things, this can give you a kind of great sense of the basic idea of these functions. So in this video, I've given you the my top highlights of Perl 1.0. If you want to learn more, like read the blog post. If you want more details than that, I'd recommend reading the news, as I mentioned, the news file, as I mentioned earlier. If you are using a deprecated function or a superseded function and want to learn what you should do now, I forgot to mention this earlier, but if you go to the documentation for that function and scroll down to the examples, you'll see that there's a bunch of examples that kind of show you like what did you do previously and what you should do now. So hopefully that will guide you in updating your code too. If you've got other problems, if we have broken something that's really important to you, great place to go is the GitHub page for Perl. Love your issues, love questions. If you do have a problem with your code, really, really useful for us if you create a reprex or reproducible example. Of course, we have a package to help you do that. So you might want to learn a little bit about using reprexes. This just gives us some like runnable code that we can immediately run. There's no like trying to figure out exactly what you did. We can take your code, see what you did, run it ourselves, and that just makes answering your question that much easier. If you have something that doesn't rise quite to the level of like a bug or a GitHub issue, another great place to reach me is on Mastodon. Very happy to answer kind of any general questions there, point you in the right direction to places in the doc. So I hope you've enjoyed learning more about Perl, and thanks for watching this video.